Fibonacci sequence. What is Fibonacci sequence and where it is originated? Leonardo Pisano Bigolio, also known as Fibonacci, is the greatest European mathematician of the Middle Ages. He is the one who studied calculation and Arabic numbers and also Fibonacci sequence. Fibonacci's Liber Abaci. Leonardo Pisano's book of calculation. So, one of the mathematical problems Fibonacci investigated in Liber Abaci was about how fast rabbits could breed in ideal circumstances. So, nakapaloob dito yung best example of Fibonacci sequence, which is the rabbit reproduction, a sequence which arises in the hypothetical reproduction of population of rabbits. Suppose a newly born pair of rabbits, one male, one female, are put in a field at the end of the second month. The female produces a new pair, so now there are two pairs of rabbits. So, sa unang month, pag pwede na makapag-meet ang isang pair, in the next month, makakabuo sila ng pair. Tapos, yung nabuo nilang pair, makakabuo ulit ng pair in the next month. So, there is a sequence happen. The sequence are 1, 1, 2, 3, 5, 8. So, it is happened when a certain pair will reproduce. So, the sequence is infinite and it continues so on and so on. So, with helps with this sequence, we can calculate the population of the rabbits. Fibonacci sequence is an integer in the infinite sequence 1, 1, 2, 3, 5, 8, 13, and so on, of which the first two terms are 1 and 1, and each succeeding term is the sum of the two immediately preceding. So, nagsisimula siya sa 1 at 1. So, in order to continue the sequence or to get the next term, we will just add the last two terms to get the answer or to get the next term. For example, 1 and 1 equals 2. 1 plus 2 equals 3. And 2 plus 3 equals 5. And 5 plus 8 equals 13. So, the simpler is just add the last two terms to get the next term. How many pairs will be there in 1 year? So, by using the formula, which is the simple rule, just adding the last two terms to get the next term. So, 1 plus 1 equals 2, 1 plus 2 equals 3, and so on. To make it short, 55 plus 89 equals 144. So 144 pairs will be there at the end of 1 year. Fibonacci sequence also be presented in squares, starting with 1 and 1, meaning we have one pair of squares in which the length of the side are all equal to 1. The next square we have has a side which the length of 2. The next square, of course, has a side of the length of 3, followed by square which a length side of 5, a square with side length of 8, 13, 21, and 34, and so on. Fibonacci numbers are said as one of the nature's numbering systems. The number of petals, for example, white Callia lily have 1 petal. Euphorbia has 2 petals. Trillium has 3 petals. Hibiscus has 5 petals. Bloodroot has 8 petals, and Black-Eyed Susan has 13 petals, and Daisy has 21 petals. Now note that not all flowers have number of petals, which is a Fibonacci number. But it is that most flowers have number of petals, which is a Fibonacci number. Here are some videos of my classmates explaining the magic of Fibonacci numbers.
What math concept is fully discussed on your assigned video? Fibonacci number appears in so many contexts in our lives and surroundings. For example, the number of the petals or spiral in a flower, the seed heads of a flower, paintings, and a lot more. In fact, the beauty of a human face is based on golden ratio, whose nth power forms the nth Fibonacci numbers. What is about this concept? Cite few more real-world cases or examples that would show the concept. Real-world example of the Fibonacci sequence is flower petals. The number of petals in a flower consistently follows the Fibonacci sequence. The famous examples include the lily, which has 3 petals, buttercups, which have 5, pictured at left, the chicories 21, the daisies 34, and so on. What are your insights about this mathematical truth or sentence? Truth. The kind of truth you get in math is a rather low level of truth. Tautological truth. Physicists use math as a tool. To whatever extent they are able to put truth in at the beginning, math allows one to derive consistent results. The choice of what math to use has to be part of the input and empirical choices.
The Fibonacci sequence is a set of numbers that starts with a 1 or a 0, followed by a 1 and proceeds based on the rule that each number, called a Fibonacci number, is equal to the sum of the preceding two numbers. Flower petals. The number of petals in a flower consistently follows the Fibonacci sequence. Famous examples include the lily, which was 3 petals, buttercups, which have 5 pictured at left, the chicories 21, the daisies 34, and so on. Certainties, it argues the mathematical knowledge does not constitute objective truth that is valid for all possible knowers and all possible places and times. In this tradition, the certainty of mathematical knowledge is acknowledged, but the concept of certainty is circumscribed and limited to human knowing.
In this video, Civility of Ted, Arthur Benjamin asked the inquiry for what valorization do we show arithmetic in school. He recommends that reasons are intended for computation, application, and less significantly motivation. The Fibonacci numbers are investigated to act as an illustration of how science can be uplifting and not simply considered to pass assessments. The associations between the numbers in the Fibonacci succession and the squares is investigated. Other than discovering various associations, genuine motivation is acquired from understanding why these associations happen. An extremely clear pictorial clarification is offered concerning why amounts of squares of Fibonacci numbers are equivalent to the results of 2 back Fibonacci numbers. Fibonacci numbers show up in such countless settings in our lives, and environmental elements. For instance, the quantity of the petals in a blossom, the seed tops of a blossom, canvases, and significantly more. Truth be told, the excellence of a human face depends on golden ratio, whose nth force frames the nth Fibonacci numbers. Leonardo Fibonacci added to the spread of decimal numbers. Fibonacci helped spread the utilization of decimal numerals. Along these lines, individuals called him the most capable Western mathematician of the Middle Ages. Insofar as I can tell, math is worried about right allowances, utilizing hypotheses, and rules of surmising. From what I have seen, explanations are called valid in case they are right allowances and bogus in case they are wrong derivations. This video closes with the explanation that science isn't simply tackling for X, it's additionally sorting out Y. Thank you.
Hello and good day, Sir Jeruel Plata. I am Josua Codrado, first year, Bachelor of Science in Criminology, Section Alpha. So the topic for today is all about the magic of Fibonacci numbers. These numbers can be appreciated in many different ways, and the elements of the sequence of the numbers. Ang unang number ay 1. Next is 1 ulit. So bakit ang sunod ng 1 ay 1? Ganito kasi yan. Ang totoong simula ng Fibonacci numbers ay 0. So umpisa natin sa 0. Sunod ay 1. I-add natin ang 0 at 1. Kaya naging 1 ang sunod ng 1. Each of which, after the second, is the sum of the two previous numbers. Ang Fibonacci numbers din ay makikita sa kalikasan, which is why you'll occasionally find a flower with 4 or 6 petals, lily with 3 petals, the daisy 34, and so on. My insight for this topic is you need to get the squares of Fibonacci and patterns to find the areas of the squares. Thank you.
So this is my answer for those guide questions of our video. So first question is, what math concept is fully discussed on your assigned video? So the Fibonacci sequence. So Fibonacci sequence is a series of numbers where a number is found by adding the previous two numbers starting with 0, 1, and so on. For example, the 5 was founded by adding the previous 2 and 3 together. That we call Fibonacci number. So number 2 question is, what is about this concept? Cite few more real world show the concept. So my answer is flower petals. The number of petals in a flower constantly follows by the Fibonacci sequence. Example is sunflower having 5 or multiples of 5 metals. That is part of Fibonacci number. So number 3 question is, what are your insight about this mathematical truth or certainties? So my answer is, mathematics itself isn't true, but all its results can be said to be true. Everything in mathematics begins with a set of assumption and definition. All proofs are pure deductive reasoning based on those assumptions and definition.
What is the Fibonacci sequence, and why is it seemingly everywhere? The Fibonacci sequence is a series of numbers in which a given number is the result of adding two numbers before it. So, if you start with 0, the next number will be 1, followed by 1, followed by 2, followed by 3, and so on. As you can see, every number in this series or sequence is obtained by adding the two preceding numbers. This simple series of numbers is referred to as a Fibonacci sequence or Fibonacci numbers. Mathematically, the Fibonacci sequence is represented with the formula f of n equals fn minus 1 plus fn minus 2, where n is greater than 1. We can use this to find any n digit in a sequence. This fascinating sequence is widely associated with the mathematician Leonardo Pisano, aka Fibonacci. He hailed from the Republic of Pisa, which is why he is also known as Leonardo of Pisa, and was known as one of the most talented mathematicians of the Middle Ages. There's another exciting offshoot of the Fibonacci sequence, the golden ratio. Suppose you have two quantities A and B wherein E is greater than B. Now, add A and B and divide the sum by A. If this ratio comes out to be equal to ratio of A and B, then you see that A and B have a golden ratio. It is represented by the Greek letter pi. So, let's think about it. Have you ever counted the petals on a flower? If you started counting them on a flower whose petals are all intact, you'd most likely notice or discover that the numbers of petals is a Fibonacci numbers. That is a number from the Fibonacci sequence. Many flowers have 3, 5, 8, 13, 21 or more petals, all of which are numbers of the sequence. The leaves of cacti and seeds of sunflowers are arranged in the both left and right-handed spirals. The numbers of seeds or leaves in these spirals are also generally in the Fibonacci sequence. We have two hands, both of which have 5 fingers, and each finger is divided into 3 parts. All of these numbers are Fibonacci numbers. Moreover, the length of the bones in hands are also a Fibonacci numbers too. To sum up, Fibonacci sequence or numbers has many usage. In geometry, when the golden ratio is applied as a growth factor, you get a special kind of logarithmic spiral known as golden spiral. Simply put, a golden spiral gets wider by a factor of 5. Ocean waves, hurricanes, snails, shells, spider webs are some of the many natural occurring examples. Architects also use this in their creative works. From snails, flower, banana, air, and galaxy, the golden ratio can be seen everywhere. If we think about it more, almost everything we see and do Fibonacci numbers or sequence are present.
Hi, my name is Jormil Betarmos, and this is my video presentation about the topic in math that has been given to us, which is the Fibonacci numbers. Well, Fibonacci numbers is really intriguing it's because it consists of numbers with a pattern. It's like Fibonacci numbers are the 1 and 1, and the next is the 2, and the 1 plus 2, which is the 3, and the 2 plus 3, which is 5, and so on. It was formed by adding the first two numbers, which is the 1 plus 1, and the result will be the sum of the 1 plus 1, and that's why it has been formed. And also, Fibonacci can be seen in nature, like in the flowers. By counting its petals, you can see if it can be an example to Fibonacci numbers, which are just like the lilies. When you can count the petal, it consists 5 petals, and 5 is a Fibonacci numbers. And about my insights in this topic is it is great for it because it gives us understanding that you can learn to identify that a thing is an example to Fibonacci numbers, and it's really amazing. That's all. Thank you.
Good day, everyone. I am Korina Bajinting from Section Alpha. I am a member of Group 1. Today, we'll discuss and respond to the 3 guide questions we were provided about our topic, which is the Fibonacci sequence. Question number 1. What math concept is fully discussed on your assigned video? So, the entire concept is based on the Fibonacci sequence. So, question number 2. What is about this concept? Cite few more real-world cases or examples that would show the concept. So, when we say Fibonacci sequence, it is a series of numbers in which a given number is the result of adding the 2 numbers before it. So, if we start with 0, the next number will be 1, followed by 2, followed by 3, followed by 5, and so on. As you can see, every number in this sequence where series is obtained by adding the 2 preceding numbers, like 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 3 is equal to 5, 3 plus 5 is equal to 8, and so on. Individual numbers in this sequence are often referred to as Fibonacci numbers. 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. Another example of this is the petals of the flowers. Mostly, flowers have petals of at least 3, 5, 8, 13, 21. Also, our hands is one of the example of Fibonacci sequence. We have 2 hands, both have 5 fingers, and each fingers has lines divided by 3. So, 2, 3, 5 are Fibonacci numbers. Last question. What are your insights about these mathematical truths or certainties? After watching the video, I learned that Fibonacci sequence is one of the most popular formulas in mathematics because Fibonacci sequence is the nature's pattern and the trademark of creator. It is related to the golden ratio. This fascinating sequence is widely associated with the mathematician Leonardo Pisano, also known as Fibonacci. He is considered to be the most talented mathematician in the Middle Ages. Also, Fibonacci sequence has been discovered and rediscovered in various forms, not only in mathematics but also in nature. That's it. Thank you.
I'm Niel Bungcag. This is a 3-guide question of Fibonacci number. Number 1 question. What math concept is fully discussed on your assigned video? The answer is mathematics is not just solving for x. It's also figure out y. Number 2. What is about this concept? Cite few more real-world case of example that would show the concept. Answer is about of Fibonacci numbers. Example of Fibonacci numbers is 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5. 5 plus 3 equals 8. 8 plus 5 equals 13. 13 plus 8 equals 21. 21 plus 13 equals 34. 34 plus 21 equals 55. That's all example of Fibonacci numbers. Number 3 question. What are your insight about these mathematical truths or certains? The answer is truths. And that's all. Thank you.
My name is Jezrel Barcelona. I'm here to talk about Fibonacci number. Fibonacci number is the number of sequence is set of the number that start with 1 or 0, followed by a 1 proceed based on the rule that each number called Fibonacci number is equal to the sum of preceding two number. Fibonacci use arithmetic series to illustrate a problem. Fibonacci is visible example today's is the branches pattern in the trees and leaves in your backyard, the flower petals that a Fibonacci number. Fibonacci is also help you in calculating the area of the box. A series of the number which each number, Fibonacci number, is the sum of two preceding numbers. Simply is series 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, and the lastly Fibonacci label are used to guide possible area where the trade could develop. My insight in the video is reveal the magnificent truth about Fibonacci number. It's help human to live comfortably, and by knowing it makes your works easier. Thus, Fibonacci number is part of our life. Thank you.
As I watched the video, it is all about the magic of Fibonacci numbers and how amazing it is. Reasons why is because these numbers can be appreciated in many different ways. Fibonacci because the person we call it was actually named Leonardo of Pisa, and these numbers appear in his book Liber Abaci. This book taught the methods of arithmetic that we use today. Fibonacci numbers can be seen in nature. Examples are the number of patterns on a pineapple, the spiral pattern of a shell. Another example is 2, 2, 4, 8, 32, and that is 2 times 2 is equal to 4, and 2 times 4 multiplying the two preceding numbers is 8, and so on. And no matter how the number goes on, with each pattern, there is always Fibonacci that is buried under the numbers.
Morning, sir. May introduce myself. My name is Jormil Kalamba. I'm section Alpha. This is my understand in the Fibonacci numbers is first is the math and concept discussed in the video is the Fibonacci numbers, also known as the Fibonacci sequence. Second is the Fibonacci numbers go like this. Example of the 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. 8 equals 13 equals 21. 13 plus 21 equals 34. 21 plus 34 equals 51, and so on. Third is the you find this pattern by adding the first and second and number to equal the third number, the fourth, the third and the fourth to equal 5 number, and so on. Thank you, sir, and maraming salamat.
Good day everyone, I'm Reymark Jan Bañas from Section Alpha. I'm a member of Group 1. I respond to the 3 guided questions we are provide about the topic, the Fibonacci sequence. What math concept is fully discussed on your assigned video. The Fibonacci sequence. What is about this concept? Cite few more real world cases or examples. That word show the concept. Fibonacci sequence is a series of number in which a given number the result of adding the two numbers before it. So if you start with 0, the next number will be the 1, followed by 2, followed by 3, followed by 5, and followed by... And so, as you can see, every number in this sequence where series is obtained by adding the two preceding numbers. 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. 5 plus 8 equals 30. And so on. Individual numbers in this sequence are often referred to as Fibonacci sequence. 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. Another example of this is the three branches. The Fibonacci sequence can also be seen as the way the three branches form or split. A main trunk will grow until it produces branches, which create two grow points. Then one of the new stem branches into tall while the other one lies dormant. This pattern of branching is repeated for each of the new stem. A good example in this sniswort, root system, and even algae exhibit this pattern. That's all, and thank you, and God bless everyone. What are your insight about these mathematical truths or certainties? After watching the video, I learned that Fibonacci sequence is one of the most popular formulas in mathematics because Fibonacci sequence is a nature pattern and the trademark of a creator. It is related to the golden ratio. This fascination sequence is widely associated with the mathematician Leonardo Pisano, also known as Fibonacci. He is considered to be the most talented mathematician in the Middle Ages. Also, Fibonacci sequence has been discovered and rediscovered in various forms, not only mathematics but also nature. Math has a lot of tricks under its sleeve. I enjoyed finding them and using them quickly tackle a challenging problem. Thank you.
A pleasant day to everyone. This is Niel Ean Cabatuan, a member of the Group 1 from Section Alpha. For today's topic, we will discuss about the Fibonacci sequence. What math concept is fully discussed on your assigned video. So, the concept depicted in the video is the magic of the Fibonacci number. Where can we see Fibonacci numbers, what they are used for, and how to calculate Fibonacci numbers. Number 2. What is about this concept? Cite few more real-world cases for examples that would show the concept. So, if you multiply the Fn, we use Fn because we still don't know what order is we're going to find with the golden ratio of 8 of 1 plus divide 5 over 2, which is equal to 1.618. The answer would be the same to the succeeding number of what you have multiplied with the golden ratio. If you will use 618 multiplied to the number n, the answer will be the preceding number of what you have multiplied with the golden ratio of 1.18. The concept is about how Fibonacci works. So, example, Fn equals Fn minus 1 plus Fn minus 2. So f sub 6 equals f4 plus f5, then f sub 6 equals 5 plus 8, then f sub 6 plus 5 plus 8 is equal to f sub 6 equals 13. And the last one is, what are your insight about these mathematical truths of certainties? So based on my understanding, the concept of the videos shows the magic of the Fibonacci number. We can see different Fibonacci pattern in nature of the and the calculation of the Fibonacci numbers, which can be obtained by adding two previous numbers in the sequence to obtain the next higher number. So that's all.
I'm Aljon Chamen from Section Alpha. Here's my explanation about the topic of Fibonacci numbers. What math concept is fully discussed on your assigned video? The concept fully discussed in the video is all about the importance of Fibonacci numbers and how it relates to the real-world cases. What is about this concept? Set few more real-world cases or examples that will show this concept. The concept of the video is all about the Fibonacci numbers, how to solve it, and how to use it properly. For example, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and 3 plus 5 equals 8, and so on. And also, Fibonacci can also see in the 8 petals of sunflower or the 34 spiral of sunflower, or an pineapple is also tends to be Fibonacci as well. What are your insights about these mathematical truths or certainties? Fibonacci numbers plays an important role in the mathematical world. For me, my insight is I think this topic is enjoy. Look at the man in the video has explained very well, and I found it is very easy to understand, and he made it fun. So I think the Fibonacci topic is fun to learn and easy.